Rational numbers. Let's continue. Observe a familiar slide which was given in part 1, and there we used these two examples to understand the easier approach, the logical approach to solve the rational numbers operations. When we have positive and negative rational numbers combined for operation, and we used the logic of combining the like denominators and grouping accordingly until we get the simplest answer, and then finally using the regular method. So observe, is it tallying with one of the properties taught to you in part 5? Observe. And today we are going to learn some more applications of the property in the same area. So exactly, it is the associative property of addition of rational numbers. Observe, it is addition, and the various numbers which are considered have different denominators, but the grouping is done to conveniently handle it, and the sum can be easily solved if we take up this method. So this is an example of usage of associative property. So now onwards, whenever use the property and simplify, the approach is this. The same can be the question. Yes, we are considering these two problems in further slides for associative property applications. The first one. Observe, 5 rational numbers are given. As it is addition, the operation is addition, we focus on the similarity of the denominators. Among the 5 given, the 3 which are colored in orange, they are having the denominator 3, 6 and 12, and the LCM of these is 12. So keeping that in mind, let us combine the 3 numbers, 1 by 3, minus 1 by 6 and minus 5 by 12. So take the LCM there 12 and separately simplify. You will get it as minus 3 by 12, which is nothing but minus 1 by 4. So extended part of the orange circled rational numbers comes to the answer minus 1 by 4. Now let us take the first two rational numbers which we have not taken, that is 2 by 7 and minus 5 by 14. Having the denominator 7 and 14, LCM is 14. So now separately add it and we obtain the answer minus 1 by 14. Observe, 14 and 4 now they become the new denominators. Minus 1 by 14, the result of adding 2 by 7 and minus 5 by 14. And the other 3 numbers, whichever we added, we got it minus 1 by 4. Now the LCM part is required. And this is 28. 14 and 4 LCM. So accordingly, we get it as minus 9 by 28. It is the easiest approach, and the property used is associative property. So question will have solve using appropriate law, and it is necessary to mention the name of the property. So it should be written. Okay, the adjacent right side, we have the direct method. Being unaware of the property, the direct approach would be this. So in case the question demands solve using appropriate property or law, direct approach is done, mark will never be given, though the answer is correct, because any property is used to make the sum very easy to solve or a simpler approach. So mandatorily we have to use the property and name it. So the direct approach, you can see the LCM is 84. Observe the denominator in the first part, it is just 28. It is not that big. Now it became 84. As 5 numbers at a time, we are taking LCM. So accordingly, when you add, taking the equivalents, that is 28 by 84, then 24 by 84, they are the equivalents of the rational numbers given. Hope you recollect. 1 by 3's equivalent is 28 by 84. 2 by 7's equivalent is 24 by 84. Minus 1 by 6 equivalent is minus 14 by 84. Minus 5 by 14 equivalent is minus 30 by 84. Minus 5 by 12 equivalent is minus 35 by 84. So now adding the equivalents, we get minus 27 by 84. But having the HCF 3 divided by 3, you get the answer same. Yes. One more sum. Similar. Observe 3 by 4, 2 by 3, minus 3 by 5, 5 by 8 and minus 4 by 15. In this, we need to see which are the denominators which need to be combined. So when 4 and 8 are combined, 8 becomes the LCM and 3, 5 and 15 are combined, 15 becomes the LCM. So go ahead in the same manner like the previous one. We obtain first bracket we simplified as 11 by 8 and the second minus 3 by 15. Simplify here itself, minus 3 by 15 is nothing but minus 1 by 5. Cancel. Simpler form. Now take the LCM, you get it as 40, a small LCM. And the answer is 47 by 40, which is 17 by 40. To the adjacent, see the direct approach. All the 5 numbers added, LCM is 120. So, accordingly taking the equivalents. So, 141 by 120 is obtained. And when it is divided by 3, the 3 is the HCF. So, we get 47 by 40. Answer same. But the approach is different and the chances of making errors less if property is used. These are the questions which was given as practice exercise in part 5. To reiterate the concepts related to the properties of rational numbers, we need this very much. Each and every sum here, true or false, observe carefully and rethink whether the property you have understood very well. Consider true or false. Each is self-explanatory. 0 is the additive identity of rational numbers. So it is given. Yes, answer is provided there. See on the top, true. And the additive inverse of A by B is B by A. It's a given. But the answer correctly stated, additive inverse of A by B is not B by A. It is minus A by B. So the given statement is false. When we write the statement as false, we need to give reason there. Because in objective type of questions, normally if the approach is correct and the answer is wrong, part of the mark is given. So we need to write the reason to ascertain that the answer is correct. For adding two rational numbers, we first need to find the HCF of the denominators. Obviously, it is not, it is LCM, so it is false. Next, rational numbers are closed under subtraction. It is true because they contain negative numbers also. Next, fifth one. Subtraction of rational numbers is not commutative but associative. Is it possible? Subtraction of rational number is not commutative but associative. The whole properties we learnt. Whenever we consider the subtraction process, it is neither commutative nor associative. Remember, that subtraction as well as division. So the reason is given and the answer also. Next one, verify that x minus y is a rational number. So x is given, y is given. You have to find x minus y, and whatever answer you obtain, check whether it is in the form of p by q. Of course, the same is done. X and y are taken. X is minus 3 by 11 and y is 5 by 22, and the answer obtained is minus half. So it is verified. Similarly, one more second one, answer obtained is 13 by 16. It is a rational number. That is the only required thing. Next, subtract the sum of minus 4 by 7 and minus 5 by 3 from the sum of half and minus 21 by 22. So find the sum of half and minus 21 by 22 first, and from that you deduct the first part, that is minus 4 by 7 plus minus 5 by 3. That is shown adjacent. So the entire LCM and how two brackets are simplified in detail it is written. Hope you have tried these, and now you can cross check what is the mistake, whether you could reach with the detailed step. Next one, multiply 6 by 13 by the reciprocal of minus 9 by 26. So it is very important, write the reciprocal of minus 9 by 26 first, then multiply to 6 by 13. So the same illustrated to the right, and we obtain minus 4 by 3 in this process, and you need to convert. It is a improper negative. Minus 1, 1 by 3 is obtained. Next, the rational number that does not have a reciprocal should be written. So that is 0, because 0 by 1, the reciprocal is 1 by 0, and we know that division by 0 is not possible, or it is not existing. P by Q form where Q is not equal to 0 is to be recollected. Next, the rational numbers that are equal to the reciprocals. So we considered especially 1 and minus 1. So with the reason, the same is explained. Last one, divide the sum of minus 3 by 5 and minus 9 by 11 by the product of these two. So first find the sum and then find the product and divide. What by what should be checked here. First, whatever you obtain is minus 78 by 55. That is sum of the number divided by 27 by 55, because 27 by 55 is the product. So ultimately answer is minus 2, 8 by 9. Next one, check whether the following statements are true or false. So just visualizing the properties. We have already studied all the properties. At a glance, you should be able to mention what property it is. And based on that, we write whether it is true or not. Say first one. It is told that minus 2 by 3 plus 0 is equal to 0 plus minus 2 by 3, which is equal to minus 2 by 3. All that explanation is not needed. Check whether the following statements are true or false. So when we see the property only, we realize, and if we want, we can verify the property also. Verification method is this. But if the question is for 1 mark, we never expect this verification. Directly we answer seeing the property. So due to this, thus the statement is true because it is additive identity. When 0 is added to any number, we get the same number. Also, it is commutative property. You can just see on either ends it is written both the ways. You can mention both additive identity as well as commutativity. Second one, we know that any number, the order cannot be reversed during subtraction. So the same is illustrated there, and you can mention the same, it is false. Third one, Closure property of addition. When two numbers are added, we again get a rational number. So likewise, for each one example is given. So if verification of the property is asked, we need to give the method. In the sense, we need to establish the truth. Otherwise, we can just write for 1 mark what is the necessary answer, true or false. So look, exact method is there. So verification along with the answer. Till now, we have seen how to use the law to verify the given mathematical statement. Now, a statement is given which is an illustration of the law. But that statement has one unknown number. As we are aware of the law and the properties, we need to use it here to find the value of this unknown number x. So let's see, first one. A rational number added to 0 is equal to x. So recollecting the law, the value of the x would be the same number given because it is the property of additive identity. We have solved it, writing the reason. So that's how x value is to be written and the reason also has to be mentioned. Moving on to second one. You can see in the LHS two numbers among which one is unknown and in the RHS two numbers. So observe carefully. One of the number is same on both sides and only the missing number which is mentioned as x has to be written as minus 40 by 41. So observation and connecting it to the law is needed. Third one more property of rational numbers. Observe, the operation considered is only one, that is addition. So there are three numbers and the grouping is done for the second and the third one in the LHS and the first and the second one in the RHS. Now observe the numbers carefully, which are the ones which are found on either side. So first, the missing number is there in the LHS and the other two numbers are 6 by 7 and minus 8 by 11. In the RHS, minus 8 by 11 is there, but the grouped number 1 is 6 by 7 and 1 is unknown. So in the LHS, it is unknown. In the RHS, it is minus half. Therefore, obviously, the number is minus half. And we have to mention the property as we are using it. So it is associative property of addition of rational numbers. Next one, two numbers, only two numbers and one number missing in the RHS. So observe carefully, 31 by 29 is appearing on either side and only the missing number is to be written as minus 5 by 12. The property is commutative property. Last one, any number added to dash gives additive identity. We have established this generalized rule. Any number, when added to its additive inverse, gives additive identity. Therefore, x is the additive inverse. So that makes it minus 4 by 5. Here, we have to see whether it is true or false based on the properties we learned. The mathematical statement is fully given. So tally it to the properties which are already learned. First one is the multiplicative identity. Direct answer, yes. Second one, rational numbers are closed under multiplication. Check, double check which operation is mentioned. So they are closed under multiplication. Yes, true. Next, third one, there are two numbers appearing on either side and the operation is only into. Therefore, it is should be commutative. Just check whether the property is having the numbers same there. Observe properly, 18 by 29. Yes, in the LHS, in the RHS also 18 by 29 is shown. 44 by 35 in the LHS. Yes, but in the RHS minus 44 by 35. So it is very important to observe the sign matters. Product of two positive numbers is always positive and it can't be negative. So even when the numbers are interchanged, they have the signs retained. So we cannot change the sign while interchanging or changing the order of the rational numbers while multiplying. So we need to consider this. So it is false because commutativity wrongly applied. Fourth one, division operation, and the two numbers appear to be same, but as two numbers are not commutative for division, so we cannot say that it is true. It is again false. Minus 3 by 8 by 11 by 18 is not equal to 11 by 18 by minus 3 by 8. We have studied. Simple examples only illustrate this. So here it is evident. Fifth one again, check properly. The answers are provided for each. Observe carefully because as soon as you see the division symbol, you say that, oh, associative property is not true for division. But see, there they have given the same. They have not given that it is equal. They have told that LHS is not equal to RHS. So the statement is true now. So the rest two also you have to check. Check the sign and check the entire statement thoroughly before you write the final answer.